Okay, we're still playing with the concept of ideal final result, and what I have to share my understanding of things. Well, it's easy to formulate the concept. It is really easy, and you have to remember only those mantras. Ideally, the system performs function itself. Ideally, product appears itself. Ideally, product appears itself when it is needed and where it is needed, and so on. So the formulation is easy. It helps a lot to formulate it. It makes a kind of concept in your head. What is difficult part of it is to somehow to come up with an idea how to make it possible. So formulation is easy, but then you have to find a phenomena. You have to find I don't know, a kind of physical effect, for example, that would help it possible. And sometimes you find it and everyone is happy, but well, I hate to say this, but maybe in 95% of cases, unfortunately, you cannot find it. Okay? It is easy to formulate that ideal, let us assume my ideal cup would fly. So it has to fly itself. Oh, beautiful solution. The ideal cup, it can all, it's funny, it flies and so on. But, well, then you have to somehow to make it possible. How to make this cup flying itself? Is there any phenomena? Is it realistic or not? Yeah, if it were made of, I don't know, of steel, maybe it could levitate in magnetic field. Well, you can consider it, yeah? If there is a lot of air circulating, it could be, you could formulate, somehow form a tornado, and you can lift it and so on. So, but you have to know what the hell is tornado, what the hell is magnetic levitation. And that is why it is really important to know physics if you want to have a creative design and engineering. Actually, all creative ideas are based on physics mostly. To this extent or to that extent, you have to know the physical background, and then beautiful solutions could come. And let's consider this one. We'll start diving deeper into complicated scientific effects with a Middle Age example of Leonardo da Vinci. If you know, hopefully, I'm sure you know Leonardo, who was a famous painter and also inventor and an engineer. And the problem, technical problem at that time, actually, it was not a problem, was how to cook, how to bake, or say grill your food in a nice way. And their kitchen oven was pretty primitive. You had just open fire. And so the system was very simple. There is a grill, so you rotate it, you rotate your food, and then sooner or later it is done. You can eat it. The problem was that when sometimes you have strong fire, really big one, so a lot of heat is generated, and sometimes it is very weak. So obviously you have to watch the intensity of the fire and change the rotational rate. If the fire is strong, then you have to rotate fast, otherwise you can burn your food. And if it is slow, you can slow down a little bit. And well, standard solution, it was not a problem at all. Standard solution was to hire a special boy. And the special boy was paid a little just, to watch the process and to control. It was perfect tracking system as far as automatic control is considered. And Leonardo didn't like it. And let us try to reinvent what Leonardo invented, and also try to come closer to his idea with the help of ideal final result. So ideal operator, and it is in my slide, is a kind of guy, possibly a trade union member, who is invited to operate, to watch the fire and to rotate the grill. Ideal operator is no operator, but the more fire you have, the faster it rotates. Okay, how to make fire rotating the grill itself. And this is a problem set up. Itselfness is very important. What is bad about operator? Because he or she can rotate the grill without fire. That means the solution is not ideal. Okay, and this is another solution when instead of operator, nowadays there is a system available in the market. You can find it also through Google. It's automation error solution when you have a sensor, when you have an electric drive and you have controller and you plug it in, and then it measures the temperature and rotates at the required rate because the temperature is sensed somehow. And it is standard solution, again not ideal. Why it is not ideal? Because it can work without food, it can work without fire. If you program it, it still can rotate. Ideally, it is able to rotate only when there is a fire on. Okay, so let's make a picture of this ideal system. Let us imagine a fire, this fire, yeah, and when there is a lot of fire, fire makes somehow rotating. And this is a picture, this is ideality, yeah. But then you have to come up with a kind of realistic engineering solution, and you can play with the temperature of the fire. You can play with, I don't know, with the color of the fire. It is quite possible you can find some interesting solution. But at that time, Leonardo succeeded in generating a very nice concept of self-rotating fire. And this is the original picture of Leonardo. This is his design. You see, very creative design. So he suggested to use a kind of propeller in the hood of the air, hot air coming from the fire, in the exhaust hood, an exhaust. Yeah. So there was a propeller inside. Obviously, if you have a lot of fire generates a lot of heat, and a lot of hot air comes up. If a lot of hot air comes up, then the propeller rotates faster. No fire, no rotation. And the rest was very simple, so you have to somehow mechanically link the propeller with the with the grill. And it is just a matter of couple of shafts and a couple of gearbox. Okay, and that is a solution. I would not say it's a solution, but very nice idea that seems very promising and implementable. Look how ideal it is, how beautiful it is. No fire, no work. Okay, that's it.